Okay, hi guys, welcome back to the show. Now, we all know mobile broadband router would wire cable to our external antennas if we need them, but does the type of cable really matter? Does it really impact your Wi-Fi speeds? Well, that's what this video is all about. So the theory goes, if you have a better quality cable with a better inner core and a better dielectric and wider cable overall, then that cable has a lower signal loss, so there's more signal going into our routers, and as a result the internet speed is faster. But does it really help? Does it really make any difference? Okay, so courtesy of Mr. Bezos, I've got a 10-meter run of some poor quality cable, some medium quality cable, and some high quality cable. The poor quality one, £20, the medium quality, £40, but wait for this, the high quality cable, 100 UK pounds. That could be 3 times the cost of an antenna from eBay. So do you really get value money for that? Okay, so to test these, I'm simply going to connect all of those cables individually to my log periodic antennas, do some tests with my trusty little spectrum analyzer, and then we're going to test the signal loss at the bottom of the cables, and then doing the same for the speed test to see what difference in speed we get. Okay, so here we've got the results of LTE band 20, that's the 800 meg band, and in this scan we've got frequencies from neg 50 down to neg 100. And we can see we've got 4 traces here, the brown trace, which is the antenna itself, we've got the pink trace, which is the signal at the bottom of the high quality cable, the black trace, which is the signal at the bottom of the medium quality cable, and the purple trace, which is the signal at the bottom of the poor quality cable. Now here we've got 3 carriers, we've got 3 UK there, we've got Vodafone there, and O2 there. And straight away we can see here the difference with the purple quality trace. That's considerably lower than that of the other traces. So there's a much greater loss with the poor quality cable than there is for the others. Now when I averaged all of these out, the average loss for the high quality cable was about 2 dB, for the medium quality was about 5 dB, and for the poor quality cable was about 8 dB relative to the antenna itself. Okay, so on to the results of the LTE band 1, that's a 2100 MHz band, and signals neg 70 to neg 100. And this bit more of a messy chart here, just one carrier there, 3 UK. And what's straight away obvious here is the difference in signal levels between the poor quality as a cable. Brown again is the antenna, pink is the high quality, black is the medium quality, and purple is the poor quality cable. And we can see here the difference in signal levels and therefore loss between the two poorer quality cables is much greater than what it was at LTE band 20, so much more obvious signal difference here. Now on average I found that the loss for the high quality cable was 4 dB, for the medium quality cable was 8 dB, and for the poor quality cable was 13 dB relative to the antenna itself. Now I did take a look at LTE band 3, that's the 1800 MHz band, but what this is highlighting again basically is just the huge difference in loss for the different qualities of cable. Pink is the high quality, we can see that's much better signal than the black of the medium quality and the purple of the poor quality, so obviously a much bigger difference here. And what this emphasises is that if you were using LTE band 7, the 2600 MHz band, and 5G at 3 gig, just emphasises why you would need a high quality cable. Okay, so on to the speed tests, and just as a comparison here we've got this signal of the router and the poor quality, medium quality and high quality cables there, and again as the reference we can see the speeds of the router itself, that's with its own antennas, is 5 meg, and that increases to 16 meg with the poor quality, 26 meg for the medium quality and 28 meg for the highest quality cable. But what's more important, what's obvious, is the increase in uplink speeds. We can see 2.1 for the poor quality cable, and that rises to 24 meg for the medium and high quality cable, so a much bigger difference there. Now in the second round of tests I did, I was getting 45 meg for the poor quality, and that increased to 48 for the medium, 53 for the high quality, so only about a 10% increase in speed per improvement in cable. But the upload, again, much bigger differences, much better improvements in speed. We can see here 8 meg going to 25, 30 meg for the high quality cable. Now on to twist 1. To begin with, I found that the high quality cable speeds of 24 meg was actually lower than that of the medium quality cable, so I was quite surprised by that. And when I checked out the reason, it was because the antennas were too misaligned, as we can see here. And when I went and realigned them again, the speed improved from 24 to 29. So that improvement of 4 or 5 megabits per second is purely because of MIMO, so it highlights the improvement from just doing that. And another twist, again looking at the speeds previously for 28 meg for the high quality cable, but then I went to try and improve them by changing the tilt and the azimuth of those two antennas, and look at the speed improvement, 28 to 38 megabits per second, purely from a small change in azimuth and tilt. Okay, so after all of that, what does it tell us? Well, it tells us that there is a clear difference in signal loss for all the different types of cable, and it tells us that the type of cable you have really does impact your Wi-Fi internet speeds. And what it also shows us is the impact on upload speeds especially, and that's going to help your Teams or your Zoom calls. And we saw that the download speeds were only improved by about 10% each time. It also shows us just how the influence of MIMO improves internet speeds. Now, does this mean it's worthwhile paying out for the high quality cable of £100? Well, in a normal situation, no, it doesn't justify it. However, if you're living in an area where you have very small signal and you're scraping from that little bit of internet speed, then it's certainly worth paying out for it then. In addition, if you're lucky to have LTE band 7 and the high capacity of that, but in particular 5G, then you really do need to use high quality cable. In particular 5G, at the 3 GHz frequencies of that, you'll suffer a lot more speed loss with the medium quality cable, so you really should pay out for the high quality cable in those circumstances. Okay, thanks for watching everyone. I hope you enjoyed the video and found it useful. If you did, then please press the usual things that everybody wants you to press, and leave comments and stuff, and I'll see you next time.